Good morning. One of the things we do regularly in college algebra is to graph quadratic equations. A quadratic equation or should I say, in this case, it'll be a quadratic function because we're going to be doing quadratic equations in two variables. Quadratic functions can be written in either the form ax squared plus bx plus c, which should look pretty familiar since you've been doing the quadratic formula, or the parabolic form, is y equals a times x minus h squared plus k. This one is called the standard form, where it's multiplied out. If we look at just a regular minimal quadratic formula, quadratic function, just a equals x squared, y equals x squared. And we plug in, say, the integers from -3 to 3. The y values are all going to be these squared. So I'm just going to go through them real quick. You can go back and pause this and slow down and recheck it to figure out where those came from. They're just the x values squared. If I graph these points, and I've got 0, 0, 1 and -1 both squared to give me +1. 2 and -2 will both give us 4. And 3 and -3 both give us 9. And so we get this curve, something like this. This is kind of hard to write on and do a graph. But this is called a parabola. Parabola. The turnaround point down here is called the vertex. And because of its symmetry to the y-axis, in this case, let me change colors a little bit. There's a line that always goes down through the middle of every parabola. And we call that the axis of symmetry. Now, in this case, the vertex is the point 0, 0. You can see that this is right in the middle of things, and when you go to x values that are the same distance, you get matching y values. So if I go 2 units away from the vertex to the 2 and -2, I get matching y values. 3 units to the left and 3 units to the right, matching y values. Therefore, these points and these points and these points. Now, a parabola can be moved left or right or up or down. You know from studying translations and transformations that if we looked at the graph of, say, y equals a negative x squared, what that would do if I kept the same x values would make all of the y values negative, and I would proceed to get the exact same graph flipped upside down over the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would get these points. Let me see if I can get this one a little closer. That looks a little more symmetrical, a little bit. If we looked at a graph like, let me get a little bit darker color. If we looked at a graph like, and it could be called either y or f of x, makes no difference. What if we looked at the graph of x minus 3 squared minus 1? Now, within the parentheses, this minus 3 would move the graph 3 units which way? Inside the parentheses is always a horizontal move, sideways, left or right. And inside the parentheses is always backwards from what you would expect. So the minus 3, instead of going 3 units in the negative direction, is going to go 3 units in the positive direction. So it moves it 3 units to the right. The negative 1 is outside of the parentheses, so that's going to move it vertically up or down in the direction you would expect. So the negative 1 moves it 1 unit down. We'll come back and come up with some actual points. But so, since this graph gets moved 3 units to the right and 1 unit down, it's going to end up over here with every single point, including the vertex, getting moved 3 units to the right, 1 unit down. So our graph, in this case, is going to look like this. The vertex is obviously going to be at the point positive 3, negative 1. And as a matter of fact, anytime you have a quadratic function that's written in this form, which we call the parabolic form, which is y equals, well, hang with me here, x minus h squared plus k. The vertex is guaranteed to be at the point positive h, because negative h would look like it's moving it to the left, but it's moving it to the right. Remember, inside, opposite direction. So the h changes the sign, the k does not. So the vertex in this form is going to be at the point, change this sign, keep this sign, so positive h, positive k. The axis of symmetry always goes down through the vertex. It's a vertical line, so the equation of any vertical line is going to be x equals whatever the x values on all the points are. This has got the point 3, -1, 3, +1, 3, 0, 3, 2. So the axis of symmetry has the equation x equals h. In this case, it's x equals 3. This is always going to match the first value from the vertex. This graph also has all parabolas, because of their turnaround shape, the vertex is where a parabola is going to have a minimum or a maximum point, depending on whether it goes up or down. In this case, it's going to be a minimum, since this is the lowest point. So this graph has a minimum point. The minimum function value is -1. And it occurs at x equals 3. The minimum value refers to the y value, the function value, but they may not say that and probably won't. But this part, it occurs at x equals, this is always going to be there for you. They'll have a box here for you to fill in, and a box here for you to fill in. So where it says the x equals, that is the x from the vertex. Where it says the minimum or maximum value is, that is the y value from the vertex. Every time. Now notice, since we've got this centered around the point 3, -1, that if I were to put in, say, a couple of points to the left and a couple of x values to the right of this, I've already worked these out, so I'm just going to fill them in. The 4 and the 2, when you plug them in, give us a 0. The 5 and the 1 give us 3. And the 0 and 6 both give us 8. If I were to multiply this out, to put it in the standard form, x minus 3 squared is x minus 3 times x minus 3. This foils out to x squared minus 3x plus 9 minus 1. So it comes out to x squared minus 6x plus 8. Now, notice if you factor this and you set the factors equal to 0, it actually factors as x minus 2 and x minus 4, which would give us x equals 2 and x equals 4, which are indeed, if we set this equal to 0, the y value is 0 when x is 2 or x is 4. So the x-intercepts occur when x is 2 and x is 4. What I want you to notice here is that the x-intercepts are always going to be the same distance away from the x-axis. The x-axis is where the x value of the vertex is. So because of the symmetry, your x-intercepts are always going to be a particular distance from the axis of symmetry. Now, it's not always going to be 1 unit like this is, but they will always be the same distance from the axis of symmetry. If we take this same equation, y equals x squared minus 6x plus 8, and instead of solving this when it's set equal to 0, instead of solving this for the x-intercepts by factoring, if I were to use the quadratic formula, where I've got a is going to equal 1, b is going to equal -6, c is going to equal 8, so that I would have -6 plus or minus the square root of -6 squared minus 4 times 1 times 8 all over 2 times 1. So doing a little simplifying here, this is going to be 36 minus 32. Now, if I split this up into 2 fractions, I've got 6 over 2 plus or minus the square root. 36 minus 32 is 4. So this is the square root of 4, which is 2. So this is 3 plus or minus 1. Notice from the other page that we had that the 3 is where the vertex is. 1 is the distance the x values are from the axis symmetry. So this point is actually 3 plus 1. This point is 3 minus 1. Here's the point I'm trying to make. Here I go. Here's the point I'm trying to make. This, simplified, leaving it in the form of the quadratic equation, is going to be y equals -b over 2a, sorry, plus or minus the square root of b squared minus 4ac over 2a. This, which corresponds to this, will always give us the x value of the vertex. This is the distance from the axis of symmetry to the x-intercepts. Now this part isn't nearly as useful because the distance could be the square root of 5 over 7. Who knows where to measure that? But this is extremely useful. To find the axis of symmetry, if a quadratic function is in standard form, let x equal negative b over 2a. This is the equation of the axis symmetry. Notice you have to have the x equals in here. It is also the x value of the vertex. Now the vertex is the absolute most important point on any parabola. So if we had a function like y equals x squared minus 8x, let's make it a minus 9. The axis of symmetry is going to be the equation x equals negative b, will be here as negative 8. A is a positive 1. So it's negative b over 2a, the first half of the quadratic formula. So negative 8 over 2 times 1, which is 8 over 2, which is 4. The axis symmetry is the equation x equals 4. To find the vertex, and if you don't have the vertex, you don't have the graph. Well, the vertex is going to be the point 4 something. We have to have the y value. If you know the x value and you know the equation, how do you find the y value that goes with that x value? Well, you go plug it in. So our y value is going to be 4 squared minus 8 times 4 minus 9. So 16 minus 32 minus 9. 16 minus 41, which is going to be a negative 25. Is that right? So here's our vertex. Now, does this graph have a max or a minimum point, a maximum or a minimum? Since a is a positive number, a is greater than 0, positive. If a is positive, then we know that we have a graph that goes up. Positive is a smiley face. Negative would be a frowny face. So since it goes up, we know this is going to have a minimum point. So we can say the minimum value, minimum function value, remember, is negative 25. And it occurs when x equals 4. Every other point will have a bigger, a higher y value than negative 25. If we need to graph this, we can find a couple more points. Now, in my math lab, you only need 2 points to graph a parabola. You only need 2 points if the first point is the vertex. There's two different modes actually that they can put graphing a parabola into. So we know we've got +4, +25, or -25, sorry. So we know we've got a point here. That's not enough to make a parabola. Now the easiest point to get would be to plug 0 in place of the x. If we plug 0 in for the x, we're going to get -9. So one of our points is the point 4, -25. A second point, we could use 0, -9. So at 0, -9, we know that that is 4 units over. My math lab will probably go ahead and graph the point the second you hit this point, to graph the whole equation. However, if by chance you needed a third point, you could just count 4 over this way. Here's 0, here's 4, so 4 more over would be at 8. So we've also got the point 8, -9. We've got the point 0, -9. And we've got the point 4, -25. And there's going to be our graph right there. Whenever a quadratic function problem refers to a minimum or maximum value, I promise you it's at the vertex. The word problems in this section, they have some excellent videos, but the main thing you need to know, for most of them, it's going to ask about maximizing or minimizing something. Watch the videos for specific ways to do it, but always find the vertex. All right, so let me know if you have any questions. I will talk to you later. See you.